Okay, welcome back. Now, these next few examples are going to be a little bit harder. They have three or four, I should say, transformations. So let's go ahead and start with number 6. F of x equals 3 times the quantity of x minus 4, quantity squared, minus 5. Okay, let's first start by listing off those transformations in order. So number 1. Remember to go from the inside out or PEMDAS order. So first we're going to start with a horizontal translation. And this one is to the right 4 units. Then number 2 is going to be a vertical stretch. By a factor of 3. And then our last one is going to be a vertical translation down 5 units. And I'm using colors to keep track of what I am doing. So horizontal translation is my blue. Vertical stretch, orange, and vertical translation is pink. First start with our parent function. Again, remember that will always be the same. Okay, now we're going to do a horizontal translation to the right 4 units. So all my points are going to go to the right 4 units. And yes, you should know the pattern by now, but I always double check, especially when I'm using pen. Okay, and then we're going to do our see if I can smear it this time. Okay, there we go. Now we need to do a vertical stretch by a factor of 3. Now in the last one, we did a vertical compression of a half, which made it flatter. Now when you stretch something, that means it's going to get longer. So when we did the last one, we talked about the points and how they're manipulated. Now you can do that same thing, or you write it down, and we're going to do that here on this one, but we don't have to do that on each one. So for example, if my first point is 4, 0, if I'm doing a vertical stretch of 3, that means my y value is being multiplied by 3. So it's still going to be 4, 0, right? Then my next point is 5, 1. That means now that point is going to be 5, 3. Next point is 6, 4. Which now means it's going to be 6, 12. Now, if I keep going, this point is going to be crazy big. So we're just actually going to go with these values here. At some point, sometimes we've been doing 7 points. At some point, when your graph gets too big or too long, you just drop down to the 5 points. So we have 4, 0, same point, 5, 3. It's a reflective point. And then 6, 12. As you can tell, the graph has gotten much longer, or you could say it's got a lot tighter. It's gone in. So it is stretched it out. Okay, last but not least is our vertical translation down 5 units. So each of my points are going to go down 5. And because this is my last one, I'm going to go ahead and connect those points. It's going to be a little bit harder with everything else going on, but you can do it. There we go. And I didn't smear the ink this time. Okay. Now, with everything, there's so much going on. Sometimes it just takes a second longer, but label your last one just to confirm we know this is your final answer. It just should be the only solid answer, but with so much going on, just give it a last final thing here. Okay, let's talk about domain, range, and axis of symmetry. So domain, any restriction on domain still? No, so we have all real numbers. And range, well, it's starting at -5 and going up. So that means f of x such that f of x is greater than or equal to -5. My axis of symmetry has obviously changed. It is now going through x equals 4. And there we have it. Right? Now, when you're doing these types of problems, they will cause a lot more work. But as you can see, there's a natural progression of how everything moves. Okay, let's go ahead and move on to number 7. Let's look at number 7. Now, we haven't talked about it in a second, but how do I know what my grid should look like? Well, the best thing to know how your grid's going to look is based on your transformations. Now, we haven't written them down, but mentally we know what they are. So I know that I'm going to have a horizontal translation. So I know I'm going to be moving left or right. And then this one I'm going to be moving left. So that means my graph needs to go to the left. I need more numbers to the left. I'm going to have a stretch and a reflection. So that means I might need some more numbers up because I'm going up, or stretching up, a reflection. So I'm going down. So it means I need a lot of negative numbers going down. And then my whole graph is moving down 1. So my graph is going to be, our grid is going to be focused in the negatives to the left because of my horizontal shift. And then my reflection and my vertical translation means I need a lot of negatives in the y value. But when you graph, again, leave a little space in case you need more room. So let's write down and talk about those translations or transformations again. Now again, remember it does need to be in order. So first we start with left to right horizontal translation. And we said that was a horizontal translation to the left 3 units. Then number 2 is going to be your stretch, vertical stretch. By a factor of 2. Now we have number 3, which is our reflection over the x-axis. And number 4, last but not least, is our vertical translation down 1 unit. I'm going to go ahead and again go through with my colors. So, starting with my parent function. As always, that's the same one over and over and over as our first one. And I start the first one in pencil. You could start the first one with black or another color if that's what you prefer. I just always started with pencil. But you can start it with a new color if you'd like it to be a fifth color. All right, now we have horizontal translation left 3 units. So everything's moving left. 1, 2, 3, and again, if you don't want to count, that's totally fine. But again, I double check with counting just because I'm also using a pen. Don't want to make a mistake with pen. Oh no, my point's gone. Well, it's supposed to be right there. So we're going to connect it like it's there. Probably would have helped if I had put my graph over just a smidge, but that's okay. There we go. Now we're going to do our vertical stretch by a factor of 2. Now again, you do not have to write down the points and multiply it like this. You can just do it in your head if you'd like. But points we have are -3, 0. And if we have a vertical stretch, that means we're multiplying y by 2. So that point, of course, stays the same. Then our next point is -2, 1. So that point would now be -2, 2. And our next point was -1, 4, which now would be -1, 8. And our last point would have been 0, 9, which obviously multiplying by 2 would be 18, and that's just way too high. So therefore, we're just going to stick with these points. So my next is orange. So we have -3, 0, -2, 2, and -1, 8. As you can tell, the more transformations happening, the more things going on, it is very helpful that there are separate colors, so everything is kept straight. Now we're going to do reflection. Everything's going to come over the x-axis. And last but not least, this whole thing is going to go down 1 unit. And this is our last one, so we're gonna connect it in a solid line. I was a little, sorry, a little bit more pointed than it should have been. There we go. And my last color. Okay, let's talk about domain, range, and axis of symmetry. Now, we can also talk about our vertex. Our vertex changed dramatically. Now we have -3, -1. Oops, forgot a comma in there. So my domain, any restriction on that domain still? Oops, so we're still all real numbers in my range. Well, my range now is going down. That means y such that y is less than or equal to -1. And our axis of symmetry is y equals, or sorry, well, y equals, my apologies. Let's start on the last one. X equals -3. Okay, we have one more to go. Let's see on number 8. Okay, number 8, our last one. H of x equals -1/3 quantity of x minus 4 quantity squared plus 1. Now, I purposely don't have anything written here, no axes or anything, because I'm going to go ahead and leave this one to you to try on your own. Now, it is on your responsibility to pause the video at this point, complete all the tasks, complete all the steps and everything you're supposed to write, and then unpause it to check your work. So go ahead and pause that now. Hopefully you paused it. Let's go ahead and check that answer now. Make sure you paused and tried. Okay, so let's talk about how we would go through this as a normal way without seeing the axis already done or the axes already done. I would actually start by doing the transformations first, because again, the transformations tell me what's happening with my grid. So number 1, my first transformation is going to be horizontal translation. And this one is going to the right 4 units. Then number 2, we have our vertical compression. By a factor of 1/3. Then we have our reflection over the x-axis. And last but not least, we have our vertical translation up 1 unit. Now, based on all of that, that means my graph is going to be shifted more to the right. It's going to be flatter, which doesn't really change much. It's going to reflect, so that means I know I need negative numbers in the y value, and it's moving up. So I need my graph to shift to the right and have some negative values, more than I'm used to. So I'm going to go ahead and make that axes now. Okay, here's my axes. Again, I focus to the right and I focus down. Start with our parent function. Yep. Try that again. Dashed line for our parent, for the original. Okay, now let's look at those colors. So horizontal is blue. So we're moving to the right 4 units. And we have our horizontal translation. Next, we have our vertical compression, which is going to be an orange. Let's look at our points. So we have 4, 0, and my y value is going to be multiplied by 1/3. So it's still going to be 4, 0. Then we have 5, 1, which now will be 5 1/3. Then we have 6, 4, which will now be 6 4/3. And we had 7, 9, which will now be 7 and, oh, sorry, and 9/3, which would simplify. Typically, this would be 7, 3. But to look at that pattern, I wrote it as 9/3. So let's look at that orange. So 4, 0 stays the same. 5, 1 is now 5 1/3. Then we have 6 4/3. And then we have 7 9/3, which is 3. And as you can tell, that graph has extremely flattened out. Now we're going to do our reflection. Oh no, I've been doing so good. Last but not least, vertical translation up 4 units. Sorry, not up 4, up 1 unit, my apology. We're going back up. It's getting a little crazy in here with all these points. Which is why it's helpful to have those colors. I was doing so well. As you can tell, my hand is now colored in multicolors. And so last but not least, we have our final answer. And mine is pink. Whatever colors your may be. Okay, let's talk about domain, range, and axis of symmetry. Okay, let's also talk about that vertex. What happened to that vertex? It finally ended up at 4, 1. So therefore my domain, which has no restrictions still, all real numbers. My range is upside, well, my range is not upside down. My graph is reflected upside down, so that means all my values are going down. So h of x such that h of x is less than or equal to 1. And my axis of symmetry is x equals 4. Okay, great job today, and good luck on your assignment.